So you're going to start out on problems where they give us a graph and they want us to find, let me move this out of my way. They want me to find the x-intercepts of the graph and then the solutions. So the x-intercepts of the graph, I can look at the graph and get those. And then what I'll do is I'll solve that by hand and see what the actual solutions are by hand. So what I want to know is these two x-intercepts where it crosses the x-axis. And remember, on x-intercepts, you got to put them in as a point. So when I click in here, x-intercepts, I'm going to use these little ordered pairs down here on the bottom of the screen. So if I click that, I can put in my first ordered pair. So you got to figure out what this point is. So I always start at the center of the graph, and you go left or right first. So let's say I'm going to go left 3. So since I went left 3, that'd be a -3, comma, which they've already got the comma for me. And then if you're on the x-axis, that y value has to be 0. So my first point was -3, 0. Then I'm going to arrow out of that, put a comma, and then grab the ordered pair again. So now I got to figure out what this ordered pair is on the right side where it crosses the x-axis. So starting at the center, I go, let's see, 1, 2, 3, 4. I go right 5. So the first number will be a 5. And then let me click over here. And once again, since that's an x-intercept, the y value is 0. So anywhere on that x-axis, remember that that y value is always 0 on those, okay? All right, so what you would do, check that answer. And then it's going to come in and ask us what the solutions are. So let me write this problem down. X squared minus 2x minus 15 equals 0. So I'm going to go to my other screen and actually work this out. So 2 ways I can solve this. And I'll actually do both ways for y'all. The first way, I'm going to solve it by factoring. The second way, I'll use the quadratic formula. Okay, so let me work this by factoring first. Now, the thing about factoring, it only works on the equations that can actually be factored. So if you can find numbers that equal the middle number, then you're able to factor these. The quadratic formula, it'll solve 100% of these quadratic formulas, okay? It'll solve them all. So I'll do this both ways to show you. So whichever method you do, you got to have a 0 on the right side, which we already got. So since I got a 0 there, I'm going to go right into factoring this. So you got an x squared in the front. That's going to put an x and an x. So here's what I look at. I look at the last sign of the last number. Since that's negative, the only way to get a negative by multiplying would be a positive and a negative. So if that last sign is negative, then you got to have unlike signs down here. Then the trick is to find factors of 15. So 1 and 15 and 3 and 5. That's the only way to multiply to get a 15. We need to find factors of these that have a difference of 2. And that would be 5 and 3. Now, anytime you got unlike signs, the larger factor that you just found always has the same sign as that middle number. So since 5 is the larger factor, it'll be negative like the middle number, and then the 3 will be positive. Now at that point, if you add them, you get a -2, right? 3 and -5 equal -2. If you multiply 3 times -5, you'll get a -15. Now, factoring, once you got them factored, you set each factor equal to 0. And then basically you're going to solve this. So the first one, I would subtract 3, and I get x is a -3. The second one, I would add 5, and get x is a +5. So that was one way to solve it. So in a second, we'll go put in our -3 and our 5. But what I wanted to do was use the quadratic formula with y'all, because it's a tricky formula. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac. All of that is over 2 times a. So basically, you got to figure out what the a, b, and c's are, and that's in these equations. A is always the first number in front of the x. So for this, my a would be a 1. Since I don't have a number in front of the x squared, I would treat that like a 1. B is always in front of the x term, so my b would be a -2. And then c is always that last number, so my c would be a -15. Now, you would come in, x equals -b plus or minus square root of b squared minus 4 times a times c. All of that's over 2 times my a. So y'all, all I did that time was replaced all the letters with parentheses so that I can now put in my numbers. So b was a -2. So that's going to give me a -2, which in a second I'm going to make that positive. B squared would be a -2 squared minus 4 times a, which is 1, and c, which is -15. All of that's over 2 times a, which was a 1. All right, so if you'll notice, most of your work is going to be under that radical for a while. So we can make that double negative, make that a +2, plus or minus. So under the square root, -2 squared. So remember, put negative numbers in parentheses for sure. When you square that, you're going to get a +4. Now, everything on the right side is being multiplied. So the -4 times the 1 times -15. So a negative and a negative is going to make that whole side positive. And then 4 times 1 is 4. 4 times 15 would give me 60. All of that's over 2 times 1 is 2 on the bottom. All right, so I can't do nothing with the numbers outside until we get rid of this radical. So I'm going to do 2 plus or minus. Under the radical, I can add 4 plus 60. That'll give me 64 all over 2. So you notice this quadratic formula is a little longer than factoring, but it works every time to where factoring might not work every time, okay? All right, so now we can get rid of the radical because I know the square root of 64. Square root of 64 is 8 all over my 2. So I'm at the point now where I'm going to get the 2 answers. So the first answer, and then I'll get the second answer. So to get the first answer, you would use the plus and add the top. So you would have 2 plus 8 divided by 2, which will be 10 divided by 2, which will give me 5. Well, that's what factoring gave me, was a 5 for one of my answers. Now the second answer, you use the subtraction. So you'll have 2 minus 8 over 2, which is what, a -6 over 2, which will give us a -3. So notice, no matter which way I did it, I still get the same answer. So factoring, if it will factor, is usually quicker, but we're not guaranteed that we can factor all of these quadratics. So this quadratic formula will solve every one of them. All right, so let's go back to our screen with that problem. So what I get, I got a -3, 5. So what they wanted us to notice on this problem is that these x-intercepts, their x values are the solutions to these quadratic equations. Because remember, if you're on the x-axis there, your y value is 0. Well, that's what I'm setting them equal to, right? 0. So any answers to a quadratic is going to be the same as the x-intercepts, okay? All right, y'all, so we got another one doing the same thing. So what's that telling me? Yeah, I want to leave. All right, let me zoom this next one in when I get there. All right, so I'm going to zoom this one in. So y'all, once again, they want x-intercepts. So I know those got to be in the form of some ordered pairs. So I'm going to put my parentheses up on the screen here. So I'll find this first one. That looks like that is at a -1, 0. So let me punch in a -1 for the x and then a 0 for the y. Now remember, you got to arrow out of that and put a comma in between the two ordered pairs. So let me grab the next set of ordered pairs and I'll find this point on the right side. So that looks like 1, 2, 3, 4, 0. So I'll put in my 4, 0. All right, so -1, 0, 4, 0. Check that one so it'll let me have my next question. And then let me write this one down. This one is out of order. I got a 4 plus 3x minus x squared is going to equal 0. So we'll go work this one out and see what we get. But y'all remember, I know what this is going to give me because we know now that x-intercepts are going to be the same as these solutions. So we should get the same answers as those x values. So this is quadratic. The first thing I'm going to do is rearrange it. Rearrange the equation. Right, we need these in order. So the x squared's first and it's negative, so you're going to have a negative x squared. Then you would put the x, which is a positive 3x. Then you would put the positive 4, all that equal to 0. And y'all, tell you something else I don't like. I don't like my leading term, my x squared term, being negative. So I'm going to divide all parts by -1 to make the x squared term positive. But watch this. I'm going to divide everybody by -1, even that 0, because what you do to one side, you do to another. But all we're doing is changing the signs. Negative divided by negative makes that a positive x squared. Positive divided by negative makes that a negative 3x. Positive divided by negative makes that a -4. And then 0 divided by anything is just going to be a 0. So this one I'm just going to work by factoring, because if you can factor them, they're a little quicker. All right, so I got an x squared, which means I got an x and an x. That 4 is negative, which means you got unlike signs no matter what. And then factors of 4, let's see, I got 1 times 4 and 2 times 2. The factors of 4 that have a difference of 3, see, anytime that last number is negative, you want these numbers to subtract and get the middle number. So 4 and 1 equal 3. And remember, the larger number has the same sign as that middle number. So since 4 is the larger number, it's going to be negative like the 3, and then the 1 would be positive. And if you add that, 1 and -4 equal -3. 1 times -4 equal -4. And then now that we got it factored, we're going to set both of our factors equal to 0. And you'll notice another thing about this. When you solve these, notice I got x equals -1 on that. These solutions are always opposite in sign than the factors. So my factor was a +1, my answer is a -1. This factor is a -4. Watch what it's going to do. It's going to change its sign so that I get a +4. So really, once you get to this point and you're factored, the rest of this problem, all you're doing is changing the signs of your factors so that you get the solutions, okay? All right, so let's see. We got -1 and 4. So let me go over on my share. And I think that's what we got on our intercepts while ago was -1, 0, and 4, 0. So we could have went straight in there and said what? -1, 4. But they just want you to sort of work them and realize that x-intercepts are solutions, okay? We just write them different. If we write them as x-intercept, we add the zeros. If we use them as solutions, we don't need those zeros, okay? All right, so you would check that answer and move on. All right, so I got 2 more problems, and this next one's going to be fun, y'all. So let's see what we got here. A wire is stretched from the ground to the top of an antenna tower. The wire is 30 feet long. So let's write this down. The wire is 30 feet long. All right, what else is saying? The height of the tower is 6 feet greater. So height of the tower, 6 feet greater than the distance from the base to the wire. And they're calling that distance D from base to the wire. So let's see what they want. They want me to find the distance D and the height of the tower. All right, so let me go to my page and work this. So wire stretched from the ground to the top of an antenna tower, and that wire is 30 feet long. So let me go to my page. So these are what y'all love, right? These application problems. So I'm going to draw what I got. So I got an antenna tower. So that's my tower. Now, I got a wire 30 feet long. So what the wire is doing is it's coming from the ground to the top of my tower here. So this is my wire. And they said it was 30 feet long. Now, they said, I don't know this distance D, right? So that's the distance D. But I do know that the height of this tower was 6 feet greater than that distance D. So that would be D plus 6, right? I didn't know the distance D, but I did know my tower was 6 feet taller. Now, if you notice, this makes what we call a triangle, right? And it's a special triangle. This is a right triangle, which means you have a 90-degree angle here. And I got a nice little formula that I can use to solve right triangles. So y'all, we will be playing with what we call the Pythagorean theorem. So Pythagorean theorem. Now usually y'all know what this one is. This is the a squared plus b squared is going to equal c squared. So let me give you a little information on this. C, since it's by itself, always has to be the longest side of the triangle. So C has to be the longest side. We got a special name for that, longest side of a triangle. Y'all familiar with hypotenuse? So the longest side is always a hypotenuse. It's always the side by itself, okay? So now what we're going to do, these two sides, it don't matter which one I make A and B, so I'll just make this A and that B. But remember, it don't matter, okay? So let's plug in for the A. For A is D. So D squared plus my B, which is D plus 6 squared. So since there's two parts on this side B, we got to square that whole thing. Now that's going to equal C squared, which will be my 30 squared. So y'all, this is basically just what they gave me. A 30-foot wire stretched from the top of an antenna wire to the ground. Then they told me that the height of my tower was 6 feet more than the distance D from the tower to the wire. So I set it up as a right triangle. So now let's see what we can do. D squared, you can't do nothing with that at the moment. That's just going to stay a D squared. D plus 6 squared, I'm going to work that on the side. So this will be my side work. So D plus 6 squared is going to equal D plus 6 times D plus 6. You gotta FOIL this one, okay? So D times D is D squared. D times 6 is 6D. 6 times D is another 6D. And then at the end, 6 times 6 is 36. When you square a binomial like this, the middle two terms will always match, and then you add them together so that you get your D squared. 6D plus 6D is 12D plus 36. I'm now going to replace the D plus 6 squared with what I got here. So that'll be a D squared plus 12D plus 36. And then over here, 30 squared would be 30 times 30, which should be 900. Alrighty, so it looks like it's going to be quadratic because I got these squared terms in here. So those are like terms. So 1D squared plus 1D squared gives me 2D squareds plus 12D plus 36 equals 900. Now, I cannot factor this yet or use the quadratic formula because that 900 over there, that needs to be a 0. So to make that side a 0, I'm going to subtract my 900 from both sides. So watch what happens. I get my 2D squared plus I got my 12D. Let's see, 36 minus, what was it, 900? 36 minus 900 is a negative 864. All of this equal to 0. Now, I will solve this by factoring. But y'all, I want to show you one thing. Do you see how every single number on here will divide by 2? So I don't like these 2's being in the front, but since all these will divide by 2, I'm going to divide everybody by 2 to make this a little easier to factor. Remember, you can do anything as long as you do it to both sides. So 2 divided by 2 makes that a 1D squared plus 12 divided by 2 is 6D minus 864 divided by 2 is a negative 432, and all that's equal to 0 still. Okay, so now I would have to try to find factors of 432 that subtract and get 6. Alrighty, y'all, so I'm going to cheat on that, and I'll show y'all another factor program I'll give you. I got one that's called Factors 2 on here, so I'll send this also. Notice it gives me all factors, and the number I want is 432. So when I punch that in, I need factors that subtract and get 6, but notice nothing on that has a difference of 6 because it's 1 times 432. Smallest one I got is 8 times 54, so I'm going to hit enter to get more factors. So I got 9 and 48, 12 and 36, no. 16 and 27, no. But look at that, 18 and 24. 18 and 24 subtract to get a 6. So I got a D plus and a D minus. Remember, the larger factor has the same sign as the middle, so the 24 will be positive and the 18 would be negative. And then set both them equal to 0. So this one will give you negative 24. Second one, you would add the 18 and get D equals 18. But let me tell you, since this is like a real world problem, there's only one answer I can take. That D cannot be negative. So since you're doing a distance problem and you got a negative answer, you're going to cancel out that negative answer. You cannot have a negative distance. So distance would be the one that was positive. So D here would be 18. And then when I found this side, D plus 6 would be 18 plus 6. 18 plus 6, what's that going to give me? 24. So 18 for my D side and then 24 for the tower side. So just remember, you cannot have a negative distance on these, okay? All right, so you go over here. So from the wire, we said that was what, 18? So you put in the 18 and then enter for check. And then enter. And then we said the height was, what I say, 24. And then enter. All right, y'all, so the last question I'm going to do of the day. Same thing, sort of, okay? So let's see what this one says. This is a ladder. The foot of an extension ladder. So ladder is 9 feet from the wall. Oh, wow. The height of the ladder reaches on the wall, and the length of the ladder are consecutive integers. So how long is the ladder? So that's all they're wanting on this one, I guess. How long is the ladder? All right, so let's draw this one up and see what we get. All right, so let me draw what I got. I've got a wall sitting here, so there's my wall. And I got a ladder leaning up against that wall. So there's my ladder leaning up against the wall. So the first thing I know is that the ladder, the base of my ladder is 9 feet from the wall. So I know this distance is 9 feet. Then it says, hey, the height of this wall and the length of that ladder are consecutive integers. So what's that mean, consecutive? That would mean two things in a row, okay? Like 1 and 2, 2 and 3. Those would be consecutive integers. So they'll do things like consecutive integers, which means numbers right in a row. they could say consecutive odd integers, which would be like 1, 3, 5. Consecutive even integers would be like 2, 4, 6. But this says consecutive integers. So let me show you what's going to happen. If I let the height of that wall be x, and I know these are consecutive integers, to get from one integer to the next integer, you add 1. So consecutive integers, if this is a number, I add 1 to get to the next number. If this was consecutive odd integers, I would have x and x plus 2. Because to go from 1 to 3, you add 2, okay? So just remember, consecutive integers are in a row. Okay? All right, so once again, I've got me a nice little right triangle sitting here. So I know that this has to be my C side, and this can be A, and that can be my B. So once again, I'm using my Pythagorean theorem that says A squared plus my B squared is going to equal my C squared. Well, A was 9, so 9 squared. B was x, so that'll give me an x squared. So 9 squared plus x squared will equal the x plus 1 squared. So let's see what we do. 9 times 9 is 81. X squared is going to stay x squared. So now we got an x plus 1 squared, so let's go to the side and do our side work and figure out what x plus 1 squared will give us. All right, so I would write that twice. And then I'm going to FOIL that. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. And then once again, add the like terms. So I get an x squared. 1x plus 1x gives me 2x. And then my 1 at the end. So I can now replace the right side with x squared plus 2x plus 1. Alrighty, so now it's time to solve this. So it looks like I need everything on one side equal to my 0. So I'm going to move the x squareds to this side. So I'm going to subtract an x squared from both sides. Oh, but look what happens on this one. I get my 81. No, those x squareds canceled. That's going to equal the right side. Those x squareds canceled. So all that's left is the 2x plus 1. So check this out. Anytime you got positive x squareds on both sides, they're going to cancel out when you try to rearrange this. So now this is not even quadratic anymore. So this is not quadratic anymore. So since this don't have no x squared terms, I don't need everything on one side equal to 0. All I need to do is solve this for the x, because I got one single x, right? So to solve this for the x, I'm going to subtract 1 from both sides. So you got 80 is equal to your 2x. And then solving that for the x, divide by 2. So 2x divided by 2 is just a 1x. 80 divided by 2 gives me 40. So I know the height the ladder is up on my wall is 40. But remember, they want to know how long is the ladder. Well, the ladder was x plus 1, which is 40 plus 1, which will give me 41. So let me go back in and put my 41. So they didn't care about the height on the wall on this one. They just wanted to know what the ladder was. So we said, what, 41, and then we move on. All right, so I'm going to stop sharing. That is it for today as far as new material. So I know some of y'all wanted me to show y'all how to do the calculator real quick, how to download that program. So let me stop this one here.